Okay, so let's begin. Welcome back, everyone, for this second day of the Python workshop. I had a question yesterday. What kind of books can we use to go deeper into Python? So me, I haven't learned with books, so I was kind of, I don't really know how it works but usually I like this collection, which is O'Reilly. Just like that, you type like O'Reilly, Amazon, and you find those kind of books. So you have several of them. Try to choose the one that corresponds to you. So this one is kind of the very introduction, learning Python. There is more advanced one, so be sure to choose the good one. And usually I kind of like them because they're very like example-based kind of books. So you really have you typing what they ask you to type, and it gives the results. It's more like a hand, you program yourself. So I kind of like it. Also, it's not that expensive. It's around 30, 50 bucks. So it's reasonable, I say. It's not like other kind of books, so it can be more than $100. So yeah, I will advise that. Haven't opened it, so I don't know really what's inside. But usually this kind of collection usually makes a good job. Question? No? Okay. So let's continue. No question from yesterday. I can begin. Okay, no question in the chat. Okay, so let's continue. So we're going to talk about data structures. So in every languages, you have a kind of way to make kind of a collection of different objects. So you want to gather together whole bunch of numbers, whole bunch of strings, things like that. So come to an object to gather other objects. And that's generally called data structure. And the main data structure in Python is the lists. So lists can store a lot of information. In Python, which might be different in other languages, the list can contain objects of different types. You can put together like a list of integer and strings and booleans if you want. So let's take an example here. So yeah, open your terminal, type Python if you're on Windows, Python 3 if you're on Mac or Ubuntu. And normally you should have those chevrons here, right? Let's do that. Everybody does it. Yeah. So how do we create a list? So I'm going to create an object here, which is my list. Why not? This name is equal to square brackets. So the square brackets will be used to create lists. Okay, just used like that. So yeah, I create my list. My empty list pretty much the same thing. So they are empty right now. So it's a list that contains absolutely no objects. What if we want to create a list of strings, for instance, that contains all strings? So I don't know, I created an object called my shopping lists equals to square bracket, and here I put all the objects I want to put into the list, separated by commas. So here is just strings, so apples, beers, and chocolate. Why not? And when I ask to Python what is my shopping list, in answering me a list of 3 strings, apples, beers, and chocolate. Lists, the order is important. If you created a list by putting that element at first, then this one, it will keep that order. So this order is important. Okay, as I told you, you can create lists that contain different types. For example, here I create a list with an integer here, a string here, and a float number here. No problem, Python is able to deal with that. Okay? For those who have arrived at last, there's a sign-in sheet, so don't forget to the attendance sheet here. Raise your hand if you need to sign it. Okay. Okay, everyone, I can continue. No question about this. Quite easy to create. So, how do we access to each element of the list? So, if you remember yesterday's, how do you access to one character of the string is exactly the same logic. So here I created a list of different strings, A, G, C, and T. And I want to access to the element at index 2. So remind you, we begin to count from 0. So in fact, when I say index 2, it corresponds to the third element. So it corresponds to C. Okay. So my nuke list, so the name of your variable, the list that you want, from which you want to have the character accessing, from which you want the character. So the name of the list, square bracket, into square bracket you put an integer corresponding to the index of the element you want to access to. So my nuke list 2 is this one. Something that you can do with the list but with strings is that you can reassign to a specific object of the list another element. So here I'm going to replace the element at index 2, but another object, which is a string, is just a G here. Okay? So for now on, when I ask what is in position 2 in my nuke list, it will be a G. And if you look at the whole list, just by typing the name of the list, you can see that this C here has been replaced by a G. Okay?
Can you replace strings?
Yeah, you can replace. Here you could have put whatever element I want. I can even make a list of lists if I want. So kind of this object. Okay. Can continue. Still hear some typing, so maybe I will wait for a few seconds. Okay. Okay, so we continue with the list. So I'm going to talk about different methods. So I remind you, what is a method? Is a kind of a function, but just specific for one object. So here you want to make an operation on an object. So it's what we call a method, and the syntax is the name of the object dot the name of the method. And to parentheses, you can put parameters if you need any. So here I create my nuke list. Normally it's already created, so don't create it again. And we are just going to add at the end another element. So we append to add at the end of the list a new element. So my nuke list dot append, and here you put the element that you want to add at the end of the list. And so it displays nothing, but when you ask Python what is into my nuke list, you have a C added at the end here. Okay. If you want the length of the list, it's exactly the same thing as for the strings. Just use LEM for length and the name of the list. You have a method called index. So here you put the element you want to search into. Sorry. You put the element that you want to search, and it gives you back the first time it encounters this element. So we'll go through all the lists, index 0, index 1. Oh, this element here corresponds to this one, so it gives you back the index at which it was. So index 0, index 1, it would be this one. Yes?
So there's two C's.
Yeah, it's the example just after. So here I have a list. My nuke list is with two C. You have a C here and a C here. And when I ask where do you find I use method index, it gives you back the first time it sees it. Okay. If I try to put into index an element that is not into the list, it gives me back an error. It said value error, B is not in the list. No problems.
And
no.
is there a way to bring up all the positions? Instead of just the first one?
Yes, there's a way to bring all the positions. I see several ways to do it, so I try to find the easiest one. So I think in index, I'm going to check that.
Is there like a pattern?
Yeah, in index you can. Yeah, I think the easiest way. I will try to remember tomorrow to answer your question because we'll see something tomorrow. But yeah, we'll see a way to do it tomorrow. So I'll try to remember your question tomorrow. But I think it will be the easiest way. Yes.
Does it ever matter to use single or double quotation marks?
It never matters. You can use one or the other. You need to be consistent. If you open with a single, you need to close with a single. And what you can do, it's not always good to do it, but you can do like double quotes, and you write something with a single quote. And that will work. So, and the other way around, you write something, you introduce your string with the single quote, double quote, and that will work. I advise you to put the escape character each time. It will still be the case because if somebody takes your copy paste somewhere, it will always work. But yeah. No other questions? Okay. How to remove element from the list? Oh, sorry. There's another one, which is sort. So you have another method called sort. It needs no parameters here. And just going, obviously, to sort your list. So from A, G, A, etc., it gives you back in the alphabetical order. If you have a list of numbers, it will give you back into the normal or the increasing order. If you have mixed lists, it will work. It will give you, it will sort it in such a way, but maybe like it will put the numbers first, then the strings, something like that. I don't really know how it is, but usually you want to sort a list of objects that are all of the same type. Otherwise, it makes not really sense. Okay. You have three ways to delete an object. So you can use the name of the, you can use the method remove, and you put the element that you want to remove. So I think it removes the first one. I doubt. I'm going to check that. And it only removes the first one. I think so. Where are you? I'm going to test it to see. You're too big. Smaller. Yeah. So let's create edge. It's going to be A, B, A dot remove. Yeah, so it removes only the first one, the first time it finds it. Okay. Another way to delete an object, rather than referring to the object itself, but rather its index, you can use this syntax. You use the keyword called del to delete. The name of the list and square bracket the object the index at which you want to remove the object. So if you do that, to remove the one at index 3, 0, 1, 2, 3, 1, 2, 3, you remove this C here. And when you ask magnus list, you can see that the C has been removed. Another way to do it, almost the same thing, is you use the method pop, magnus_list.pop, and here you put the index. The only difference with before is that as a result of this method, it gives you back the element that's been deleted. So if you have like my element equals to magnus_list.pop 1, my elements will be equals to A. So you can keep track of what you have removed. Okay. When you ask what magnus list, it has removed the first A here, this A here. Okay for everyone? Oh, I have a question here. It does remove the first element. Okay. Yeah. So it's kind of similar of what you have done before with the string, but with more information. So here I create a list of strings, letters, let's just say, and I do slices. So I want to have, yes.
Is there a way to just undo a command?
No. There isn't, of course, you can undo what you have just done, but depending on what you have done, it will be different. Does that make sense? There's not Control Z if you want. If it was your question, there is no Control Z. So basically, when you did an error, you need to the up arrow to create a new list and to do the subsequent elements.
Is that for terminal and like other?
Sorry?
Is that for other text editors too?
So yesterday we did something on the modules. What your question is?
Or like if you're in Sublime, can you like copy and paste like the correction to that?
Okay, so if you are, I'm not sure of what you're saying. If you're in the terminal here, so let's just say, oh, I should have not removed this A here.
Yeah.
Then the way to do it is just you come back and you create a new the list with the up arrow, and you need to like I wanted to remove the B, like, so, and you need to correct it like that. Okay, so that is in the terminal. If you have a text editor like Sublime or a TextEdit or Notepad, then you go back to your file, you save it once again, and and if you are using it as a module, you need to exit Python here. So I will need to do exit here to go back into Python and to report once again the module. Okay. I know that's a little bit annoying that way, but yeah. So have a list of strings, as you say. And now we're going to use slices, what we call slices. So it's just like you put square bracket and you separate indexes by column. So what does it mean? Here, letters from 0 up to 2, it says that I want to have access to all the elements starting from index 0 up to index 2, but without including this one. So I want the elements 0, 1, 2 without including these guys, so just A and B. Of course, programmers are very lazy people, so there's a shortcut. If you will always begin from the beginning, you don't have to specify index 0, you just put nothing here, and just put directly column, and put the end index. So here I want all the elements from the beginning up to index 4 without including the last one. 0, 1, 2, 3, 4. I do not include this one, so it will be everything up to D. The same thing the other way around. If you want all the elements from a particular point up to the end, you don't need to specify the last index. You can just put an empty, put nothing here, just one column. It will take all the elements from index 1 up to the end, right? Be careful, yesterday, just like for the strings, if you want to access an element which is out of the bound of the indexes, it will throw an error. So it says to you, list index out of range. But if you use the slices, so here I want all the elements from index 7, from index 6 up to index 7 without including the last one. So I want to access an element that should be here. It does not throw you an error, it just gives you back an empty list. Okay, so obviously, it does not give you an error, so be careful about that to be sure that when you use slices, you are into the bounds of the size. Okay.
I have a question. Is there a logic to that it says 0 to 2, but you don't include index 2?
Yeah. So it's always the logic if you have two kinds of languages. After they begin to count from 1 and they include the last element, or you begin to come from 0 and you do not include the last one. The idea to that is that, like, let's just imagine that you have A, which is 1, 2, 3, 4. Let's just say that, and B, which is 10. Or I could have just put the numbers without the strings. 20, 30, 40. So if I want to create C and say it's going to be the two first element of A, and I want the two last element to be the two last element of B. So the way I do that, I can do something like that, up to index 2, plus B starting from index 2 up to the end. And you put the same number here and there. If it was including the last one, so it means that you should put a 3 here and a 2 here, which is kind of counterintuitive because here you just take 2 elements and here you just take 2 elements, but yeah, something like that. So it's kind of this nice way of seeing things that I think why they choose to do that.
Yeah.
Okay. I had another question over there. Yeah.
What if you don't know how long your list is and you want the tail end of it? So you would use -1, but you can't get -1 because it's from the one before that on.
So the element -1 would be this one, right?
Right, but if you ask for it to give you like 2 to -1, it stops.
So you want, okay, so let's just say that you want,
The final,
if you want those 2 elements, you want to write something like from index 1 up to index -1,
right.
right? It will work, it will give you exactly that, I think so. I'm going to check, of course.
No, that would work. But what I'm asking is, what if you don't know how long your list is,
Yeah.
and you want the last 3 elements of it, how would you get that? Okay.
I think so. Yeah, I'm almost sure it works. So I take, let's just say A -2. Yeah.
Thank you.
Yes.
What if you want elements like the first, the second, and then the last one? You want to get separate slices from separate areas.
So you want the 2 first one and the last one, did you say?
Yeah.
So you need to put like a plus sign. So let's
So if
just
you
check.
look at the B example, but just another A, like C equals A.
Yeah. So you do something like I want the 2 first elements. So it will be this one and this one. Plus, so you need to have a list. So it will be, let's just say the 2 last elements. Let's imagine that it was longer. And you will do something like -2. So that will create you a list with the 2 first elements. And you plus adding together two lists is just gluing them together, just like the string. So it gives you like that. Okay? Please tilt your camera a little bit down. So sorry about that. Up. Sorry, I don't know where they ask that, but up. Yeah. Okay. No other questions? Okay. So there is another data structure different from the list, which are called dictionaries. And the idea is like a paper dictionary. From the paper dictionary, you have a key, that is the word that you want the definition of. So that will be the key. And the value, will be the definition. So you have to imagine that. The key is to access the thing that you are using to access to the value, okay? So the way we do it in Python is you use brace brackets here. You can see here and here. You separate the couples, key value couples by comma. And you put your key here, column, the value corresponding to that key. Okay? So if with my paper dictionary, it would be like, here would be the word in question, and here would be the definition, for instance. Comma, another key, column, another value. As a key, you can put whatever you want. You can put strings, you can put numbers, whatever. Usually it would be strings. In all the examples I used, it has been strings, but it's not mandatory. So you create a dictionary like that. Be careful. So I think in Python 3.7 it might change, but think that the order does not matter. It's not because you put control here first, then X1, then X2, that it's going to sort it in the same way in your memory, in the memory of your computer. So for instance here, it chooses when I ask it to display it, it has changed the order. It made first control, then X2, then X1, even if it's not the same order in which I enter it. So if you want to have an object in which the order is important, use lists. If you don't mind too much the order and you have this thing of I want to make something correspond to something, as you'll see in examples later, rather use dictionaries, okay? So once you have created your dictionary, how do I access to the elements? So in fact, the idea is rather than use the index, you are going to use the key. So here I put the name of the dictionary, square bracket, and here normally if it was a list, I would have put it. I will have put the index, but here I'm going to put the key. So what is corresponding to that key in that dictionary, and gives you back the answer. So from X2 it was 600, so it gives you back 600. You can use it with another key, control for instance, 1000. And just like for lists, you can reassign. You can either reassign or you can create a new key with that syntax. Experiment, square bracket, the new key that you want to insert, or an old key that you want to reassign. So let's just say I want to add a new experiment x3 equal to the value. And for non-experiments will be, you see that x3 has been added here. Of course, it does not add always at the end. It can be added at the middle or whatsoever. If you want to delete an element, you can use the same kind of syntax as for the list. Use the keyword del, experiment, square brackets, and here rather than putting the index, you are putting a key corresponding to what you want to remove. And the same thing for pop. You can use also pop, the name of the dictionary, experiment.pop, and here you put the key and gives you back the element that has been removed. Okay for everyone? No questions about that? So we are going to put into application what we have learned by doing scripts. You have question online? Okay. Scripts. So what are scripts? So here I remind you that there are three main ways to use Python, to run some Python code. The first one is what you have done just until now, this afternoon, is you open Python by typing Python in your terminal. It opens you Python and you write some code, and you just like step by step doing what you want. Yesterday we did a module, that is to say that it's a text file. You write one whole bunch of functions, and then when you finish to write it, you save it into a file, you come back in your terminal, you open Python, and you use the syntax import the name of your module that you have created, and then you can access to the function you have defined. That was the second way. And the third way is the one we're going to do right now. It's a little bit different than the module. You still open the text file, you still write things in Python to the text file, but you are not going to go into Python to execute it. You are going to be directly in your terminal in order to execute it. What I mean by that is yesterday we did something like that. We open Python and we say from workshop import something. Here we are going to do something different. We are outside Python. There is no like chevrons here. As you can see in the slide, there's a $sign. Maybe in, it can be also sometimes, I think in Windows it will be just a chevron, just one, not three of them, something like that. And you just type Python 3, but directly after you write the name of your file, okay? So you see an example, it's tip calculator, okay? If you are on Windows, you type Python here. Is it okay for everyone? So be careful. Each time I have some people who are confused. If on my slides you see chevrons, it means that Python needs to be open. If you see a $sign, it means that you need to exit Python. So just type exit and starting from here. Okay for everyone? Okay. Like yesterday. So if you are familiar, if you are Windows, use Notepad. If you do know Sublime Text or JEdit or Emacs or Vim, things like that, you are free to use it. If you don't, if you're on Mac and you don't specifically know any text editor, use TextEdit. But once again, be careful, and those things tend to come back regularly, even if you did it yesterday. So TextEdit, whatever, done. Okay. TextEdit, where are you? TextEdit. Okay, new documents. Okay, so if you are like that and you see like this ruler here, etc., it's not good. Okay, so if you see that, stop right away and just go into Format and click on Make Text, the main plain text. You click here and just remove the ruler. It's not finished. Even if you are here, it still might not be good. You need to go into Edit, Spelling and Grammar, and remove this correct spelling automatically. Otherwise, it will put you an uppercase at the beginning of the line. It's not what you want. Okay, be sure to uncheck that and go into Substitution. Remove the smart codes, smart dashes. Remove everything. Uncheck everything. Be sure to add that. Once you have done that, you're ready to have a correct way to use gedit. To use TextEdit, and you can begin to write. Okay, for everyone? Sure? No question? Yeah. Okay, so we are going to create a very small script. So me, I'm a French guy. I arrived in the United States, and in the United States, we need to tip. I've never done that in my life. I don't know what are the percentages and so on. Also, the tax is not included. So let's just say I want to create a Python code to take into account that. Okay. So we are going to create a script. So we are going to open. You see, there's a white background here. So it means it's your text editor. I'm going to create a tip calculator. So I try to name my file tipcalculator.py. Save it in your home directory, the directory in which there is this small house. Be sure to do that. And here I'm going to create this file. So I just write pseudocode. So okay, to calculate the price of the price of the tip, I need to set the cost of the meal, then to set the rate of the tax, then to set the tip percentage. I will calculate what is the price of the meal, including tax. And I will calculate and return what is the final price, that includes both tax and tip. Easy enough. I'm going to translate into Python. So I try a little comment here, calculate the cost of meal, tax, and tip. So I set the cost of the meal. Let's just say that it was an expensive restaurant at $44.50. Here I'm going to put the tax rate, which is 7.5%, so 0.0775. And the tip is going to be, like, just say 50%, so 0.50. Okay. Then I will calculate the price of the meal. So the price of the meal is going to be the price of the meal plus the certain percentage of the price of the meal that does not include taxes. So I remind you that Python is computing that gauge here with the previous value of meal, which was 44.5. He sort this, calculate that, and then he store it into meal. So from now on, meal will include the tax. Then I put total, would be the total price, is going to be the price, the new price of the meal that includes the tax, plus the price of the meal times the tip. Okay? And then I'm going to print the result. So it's a kind of weird thing here, percentage 2.2f. What does it mean? So you remember, I remind you, yesterday we have something like percentage s. Percentage s was meaning I'm going to insert a string here. Okay? You can do the same thing with numbers. So I'm going to insert a number with a certain formatting. So here what I ask is, so the f indicates that I'm going to insert here a float, something that looks like a float. But I just want two decimal precision, because I don't want to have 1,000th of a cent. I don't care about that. I want to have the cent precision because we are talking about dollars. So here I said, okay, print me the floats, but just having 2 decimal precision. I get rid of the others. Okay, so it'll just print you something like, I don't know, it will be something like 55.72, and it's not going to go further away. Question? No? Okay. Is it okay for everyone? Yeah.
So can you explain again the meal equals meal?
Yeah. So meal at first is 44.5. In fact, the equal is not that much a math equal sign. It's more like an assignment. So here, what I write that, I mean that I want to assign that value to that variable. Okay, and when I use meal equals meal plus tax, or whatever meal plus tax, what Python does, it first look at this part of the sentence, just concentrate on that. Until now, meal has this value here. So it will replace that meal here by that value, and this meal here by that value. It will solve this equation, do the meal plus etc. It has a new value here, like, I don't know, $50, something like that. And then it will assign a new meal to be the solution of that equation. Okay. So in a sense, it's not like, since I said that this equal sign is not a mathematical equal sign, it's more like an assignment. So you can imagine an arrow. I could do that here. Is it okay? Okay.
Can you also use the arrow?
No, you cannot. I use the arrow because other languages use it in Maple. They use this arrow because Maple is dedicated for mathematicians. So they want to keep the equal sign to be a real mathematical equal sign. When you're more like languages that are more applied to be made by computer scientists, it will be more an equal sign. Most of the time, is an equal sign. Maple, mathematics. Usually, yeah, languages that deal with mathematics, they don't like to use the equal because it's,
R, I think, does both.
R maybe does both. Okay, I don't know. Yeah, maybe you're right. Okay. Okay, so I save it in my home directory, so in my here, and I'm going to execute it. So be sure to exit Python. Sorry, I insist, but I know each time students are confused by that. So you are outside Python. If you see some chevrons in your terminal, you need to exit it. So use exit, run brackets. If you do that, you have something like a $sign, meaning that you are outside Python, or maybe a single chevron if you're on Windows. ls, so ls is to list directory. If you're on Mac, you can see that you have your, so workshop.py was the one from yesterday, but you have tipcalculator.py, which is the file the script that you are going to execute. Okay, so be sure that it's here, it's this directory in which you are. And then you use Python 3, or just Python if you're on Windows, the tipcalculator.py. And hopefully, if you didn't make any mistakes, it will give you back the results here. I'll let you do that. If you are not managing to have that, raise your hand. I will come to see you. Yeah.
We have like input next to string. Sorry, if I use this command, what I can do is a string.
We'll see.
Okay, sorry.
So ls is just a command into the terminal, just to list what the file is. Yes. So there's a whole bunch of files here. This is the workshop. And so you save it. So tipcalculator is not here, so you can save it in the front page. calculator. Now you can use the last line, Python 3, and the calculator. Who needs help?
I typed it in. It says it's not.
Okay, so you are inside Python here. You see the addition of
Oh.
now you should exit. Yes. So Python 3. No. It's Python 3 and the name of the script here. You use the tab. So it says that there's no such thing. So I just want to get. So. You use the arrow to yeah. Okay, yes, because it's here. Okay, so use this one. Yeah, if you are in Windows and you want to list your what's the content of your directory, use rather than you using ls, you use dir, dir. Other question? Yeah. So calculator is here. Okay, so there is an error. It's the same. So. Did you copy paste from text edit?
I was just opening them.
Yes. So go back here. Go back into the text. I don't know why, but you changed the codes. So the codes, your code is always the same thing. There's, rather than being straight codes like that, it's doing it like that. Okay, everybody managed to have like 55.01? Okay, so maybe you already used Unix system. I mean, you use the terminal to execute programs. So usually, when you do that, if you don't worry, it does not matter. But usually, what the syntax is that you have your name of your program. I don't know, like you want to create an archive. You put some element here, XR, and here you put the element. You want to put like the file that you want to compact. So it's always the same kind of syntax. Here you put the name of the the name of your program. Then you put some options here. So that is the syntax into the Unix system. Just finished. And we want to have this kind of same behavior. So you want to write the name of our program and add some information here. Yes, what is your question?
It's a little separate, but if you accidentally close your command prompt, is there a way to open it with the previous code?
So you exit Python, and you want to open it and to have a new the comments.
Yeah, the whole command prompt window closed.
Okay, so you need to reopen the terminal. So like you're on Windows, right? So you type Python, and you need to use your up arrow to go back in your history, and you need to execute everything which is relevant. Does it make sense? So let's just imagine I've created. So here I have A. A is the list, and by mistake I either closed the window or whatever. but I'm exiting Python. Oh, I need to come back into Python. And here A is no longer known. It does not know what it is. So I need to come back and find with the up arrow, it will go back into the history of all your commands and gives you back the moment where I defined the equation. And here it goes. Okay. There's no way to save when you have Python is a software. So when you execute it, everything you have executed is lost. They just keep a history of the commands, but it does not execute it. Okay. Okay. So I'll go back here. So typically here, I don't want to create each time to open my text editor and to change the price of the meal, etc., and to come back into my terminal and execute it again. I want directly want to specify what is the price of a meal here. So I want to add after this line here, like I don't know, have another meal at $20, and like specify the tip. Okay, because maybe I'm more happy, I want to put 20% than 50%. So how do we do that? So basically is what I explained. I want to put like a string like that when I add the price of the meal at the end. Okay, if I type that, I want that to be executed. So I have a question here. Plenty of question. Oh, whoa, la, 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 la. So yeah, so on Windows there is dir to list all your comments. Yeah, so those always gives results. No, so I'll come back here. Sorry, I'm answering questions of people online. So here I have a syntax, %.2f, to have the 2 decimal precision. If you don't put it, like if you just put like print total and that's all, it will print with a lot of precision. So like if total is I don't know 44.777377, it will print all of that. Okay, so I just want to display it in a nice way, which makes sense when you are talking about dollars, just having 2 decimal precision. So it will print you as with the full precision. Dear workstand, I can get it work on Windows. Got it. Okay. Does Python always give results in integer? Yes, I'll answer this question. For Python 3, if you do %s, it gives decimal. It only gives integer if you put %i. Yes. So I haven't mentioned that, but if you want to insert at a certain point in your string an integer, you use %i rather than %f or %s. There is also the way if you want to display a number in the scientific notation, so rather than having the float number, but like having 3.5 times, it will use a small e10, something like that. It's a %e, and you can specify %.2e with 2 decimal precision, things like that. Okay. So how do I do that? How do I access to the element that the user is putting at the end of the command line, and including it into your software, your script? Sorry. So there is something called sys. So there is a module. So you remember yesterday we imported the module called math. There is another module called sys. Sys is for system. And sys has, in particular, a list called argv, argument variable here. And the only thing that I'm doing here is exactly the same thing as you have written before. I just add 2 lines at the beginning, which is import sys. So I'm going to import that module and just ask Python to import whatever is in sys.arv. And sys.arv is going to be a list, as you're going to see. You save that file, you come back to your terminal. You have a $sign here, meaning that you need to be outside Python, and type this command line. Python 3, tip calculator, and here you can put whatever you want, or arg1, arg2, or you can put numbers, whatever, and separate them by spaces. Okay, so here I choose to put arg1 space arg2 space arg3, and but I could have put whatever I want. Okay, so when I execute that, so please do it if you don't have it right now. I'm going to explain what it's doing. So just do line thread at the beginning. Yeah? That should not be too long. So what it does, so here I ask Python to print me what is in sys.argv. So it's the line corresponding here. I'm just going to print what is sys.argv. The first one is just the name of your program. So typecalculator.py is the first element of sys.argv. The second one is going to be that element here. Whatever you have written here, if you have written like 1, 2, 3, 4, 5, you will display here 1, 2, 3, 4, 5. Then the second one, the third one, and each time it separates corresponding to the spaces you put here and here. Okay? So that's cool. It means that you have a way to access the different elements that the user have written at the end of its command line. So you can use it. They say, oh, okay, so I'm going to take the first element that come afterward the script name, and I'm going to say that is going to be the price of the meal. And then the second one is going to be the percentage. Okay? So I'm going to use that. So let's do it, right? Everybody managed to have that? Yeah? Okay. So here is the old version here. I'm just going to change two things. So I'm still going to import sys. I'm going to remove that line because I don't need it anymore. And I'm going to say that meal is no longer 44.5, but it will be whatever the user put into the command line at the position of index 1, because index 0 is the name of the file. You don't care about it, but the one at index 1 will be this one. So it will be the price of the meal. The tax rate is always the same, let's just say, so we'll just keep it that way. And the tip, we are going to put it as the second element the user put at the end. Okay? So 50%, just imagine. Okay? So you save your file, come back in your terminal, and type Python 3 tip calculator. Let's just try with $20 meal and 50% tip. Let's try it. Does it work? Yeah. For who it works? No, nobody. That's normal. So, okay, I'm just going to check that.
Question.
Original version. Okay.
Yeah.
Go ahead.
What's the 0?
Sorry, say it again.
What's the 0 one? So
So is sys.argv0, so I'll come back to previous slide. Sys.argv0, the element 0, will be the name of your scripts. Okay? So here I decided to call it typecalculator.py, but if you have to choose another name, the sys.argv0 will be the name that you have chosen for your script. Okay? Okay, so something is wrong. You can see. So it tells me something like type error. Okay, so it deals with types. Can't multiply a sequence by an int of type float. So something is wrong in the multiplication. Something went wrong in that multiplication. It indicates the line in which there is a problem and tells you that I cannot make the multiplication. Can somebody understand what's just happened? Yes?
Is it taking these arguments as strings?
Yeah, exactly. So if I come back here, when I ask Python to plot what is in sys.argv, you can see that it's a list of strings. Okay? So what Python has done, it has considered that sys.argv1 is going to be a string, so it stores into meal, which is a string, and try to multiply a string by a text, which is a float, and cannot make the multiplication of a string by a float, so it tells you that there is an error. So in order to solve that, we are going to transform that string into floats, okay? So it's what we are doing here. So here, rather than having just sys.argv1, I'm going to take that element that is a string, transform it into a float, and the same for the tip, and it will work, okay? No errors. It works. No question on the chat. Okay, so it works. Perfect. No problem. Raise your hand if you have a problem. Don't hesitate. Okay. So basically, you know how to. Oh yeah. Go ahead.
So why do we do this instead of the functions that we were yesterday?
It's a different logic. Functions is something that you are going to use later. You just like, or you are going to use several times, or things like when you have this logic behind here. Here is a very small thing, just to calculate something very quickly. Of course, I can have, if I need to calculate the tip for plenty of different prices at once, then yeah, maybe I will create a function, def something, and I put the tip, etc. And then I can use that function either in a script or either in the interactive environment if I need, and I will use that. Okay. So, you know, typically I use scripts for you want to have a raw data, okay, and you want to apply you remove all the data that are with null. You want to clean up data. So I just something like basically the only argument that you need is the name of the file in which there is the data. Okay, so you can use a script, so write it like that without any functions, and just use sys.argv to be the name of the file that on which you are going to execute that, and then you do it. And then if you need to do it on another file, you just have to change the name of the file. If you want things more complicated, like you want to create a software that does different things, and like the user can do something or something else, it's more, you're going to beginning to use functions if you have a software where the user can interact with it, for instance, you know, something like that. Other questions? Yes?
Is there any benefit to using an input within the script as opposed to this? So let's say you did like meal equals input.
The function inputs, well, no specifically. I mean, it depends on the logic you want to have. One thing which is cool with that is with that syntax, you can create. So, are you familiar with Unix typing system? So you can create a bash file, which is going to contain plenty of those kind of lines. For I don't know, you want to do it for plenty of files. You just copy paste with changing the name of the file, and you just execute that bash file. So once you execute that, you go for the first line, and will execute it like that. So it's just an easy way to do it. If you have an input, then it's very, I mean, it's possible to create a bash file that deals with the input, but it would be kind of cumbersome. I try to do it, and it's not easy to do. To interact, if you have this question and answer that, you know, automatically do that. So yeah, it will be my answer. Other questions? Yes?
My terminal keeps closing when I do the exit.
Okay, so I know why. It's because you oh. You use it like that? Mm-hmm. And can you do exits?
Yeah, it doesn't have to
Okay. Let's just say that open Python, exit Python, and like in 2 minutes it close.
Yeah, when I exit Python. Like if I open Python and I wait a few minutes or do something else, like in Python and then exit, then it close.
Okay, so like you open Python, you do like something else. A is equals to 1 or something, and here you exit, and close the list. I don't know. The simple answer, I don't know. If it does really like that, it's not your fault. It's a problem. It's closed like, how does it close?
Go with those scissors. I'm gonna have to be
Because maybe you did something which is not that. Maybe you just use like Python and you open this that.
No,
No,
I'm
you,
command.
you use the terminal. Well, I don't know. If it happens, it's closed, so you use exits. You use exits.
So like I'll do this and when I get it.
I understand. Okay. So, I know it's understand. So in fact, it's when you are inside Python, then you use exits to exit Python. So that way, it closes the terminal. Okay. Other questions? No. Okay. Yeah, so you can test it with basically. It's just, oh yeah. Oh, it's it was one question about the functions. So I haven't remembered that I was doing that in the next slide. So yeah, a question about the function. So let's just it's not mandatory here, but just like to practice, let's create a function inside your script. Def calculate tip, and it's going to have 2 parameters, meal and tip. And the rest is the same, just don't forget to have the return total. And so it's definition of a function. So def, you have a column at the end. If you have a column, the next line needs to be indented. So be sure to have everything here indented. And that. And the last line here would be, I'm going to print with a 2 decimal precision. Whatever is the result of the function calculate tip, that contains 2 arguments. The first one will be sys.argv1, and the second one will be sys.argv2. So meal here makes sense, the name meal makes sense only the definition of this function, and tip is the same, and you are going to call that function with those 2 arguments. So sys.argv1 will replace meal here, it will be replaced by the float, etc., and the same for the tip. Okay? So what Python will do? So you said Python 3, tip calculator, etc. Python will go through that file. It will first import sys, and here it will define a function. So just it will open a box, put the definition of the function inside, close the box, and ready for you, and wait for you to use it. So it does that. So basically, until then, he has done nothing except putting the definition of the function aside, and then it executes this line. Okay, so he's going to execute that. Okay, so I need to print something. What am I going to print? So I'm going to execute that line here. So to execute like that line here, oh, I need to insert something here. What do I need to insert? Oh, it will be the result of that function. So I'm going to execute that function. So I'm going to execute that function with that argument and that argument. So it goes back in the definition of the function. It execute all those kind of things. It returns the total. Okay, so don't forget this line here. That will be the result of that function with those arguments. So I'm going to insert it here. So I'm going to print that statement. That is going to be that. So plenty of things that are happening in just one line. Okay. So it can be useful if after that you want to continue the script, you use calculated plenty of times, something like that. Okay, I've already managed to have that. No questions? Let's continue. That's two different examples. If I put 20% tip. Okay? Just checking. Okay for everyone, I can continue. For loops. So for people already programmed, normally you are familiar with that concept, but basically it's not a big issue to understand. Sorry about that. So the idea is you have your script, let's just say, and you have different statements here. You need to execute different program statement, and at some point you have like a list, for instance, and you want to do something for each element of the list. So you are doing a for loop. For each element of the list, I'm going to do something. So it will go for the first item. It will execute some statement here with that element, and then you go back here, you go back to the second item, etc., until there is no more item in the list. And in that case, it continues the program. And as always, I always forget to deal with that. I'm going to write it down. In this name. So yeah, the problem is just like it goes to the line, it should not. So that those two lines should be just one line. So for variable in list name column, if there is a column, the next line is going to have an indentation. Okay. So that should be the one line. Just going to do examples just after that. So let's go back in the interactive environment. You are going to open Python because you have some chevrons here. So be sure to type Python or Python 3 if you're in Mac or Windows. And let's create a list, my list, 4, 3 point something, whatever you want. Close, just put numbers, otherwise the example won't work. And we are going to use a for loop. So here I decided to create the name of the variable. I call it a number with an underscore. So you can create name of variables with underscore in my list. And I'm going to print 2 to the power, 2 star is to the power of a number. So when you do that, we do something, student tends to be a little bit disturbed because like a number has never been defined before. I never wrote a number is equal to something. So they're kind of lost in saying what is a number. We never defined it before. In a sense, we are using it into the definition of the for loop. The reason for that is a number is going to be an object that you are going to use in order to make this statement here. So it's like the name of the variable into a function. The name of the parameter into a function is something that makes sense only in the definition of the function and not outside. It's a kind of the same thing here. A number would make sense only in the definition of your for loop and not outside. Almost. Let's just see that way at first. So a number makes sense only in the definition of the function here. And a number will subsequently be equals to 4. and then it executes that line here, that statement with a number being equals to 4, then goes back here, and then takes the next element. So at the second step, a number will be equal to 1. It will execute that line here, come back, a number will be equal to 3.4, etc. It will execute that line with a number being that number. Then it goes back here. There's no number anymore in the list, so it continues the program. Is it clear for everyone? Sometimes people are confused with that. So a number is something that you're just going to use into the for loop definition, and normally you are not going to use it outside. Okay? And it will subsequently be each element of the list. Yes?
I'm so confused. How does it understand that it's from that list and it's
Okay. So my list is here. So the information which list you are looking for is after the keyword called in. Okay, and here that guy here is just the name of the variable. You can put whatever you want as always, but it's just going to refer each of the elements of the list subsequently. Okay, so the for loop will. So if I go here, so the first step, the first time you encounter this, Python is encountering this for loop, you say, oh, for a number in my list. Okay, so I'm beginning at the beginning of the list. I take the first element, which is 4, and I'm going to say, so for right now, a number is going to be equal to 4. I go here, and I print whatever the result of 2 to the power of 4, because a number for now on is 4. Okay? It finished this line, so it comes back at the beginning here, and here it takes the second element. So a number in that step is going to be equal to 1. It prints that, it comes back here, a number is going to be equal to that, etc., and until the end of the list.
just as a placeholder.
Yeah, it's just going to refer to that. I see that a question line. Yeah, a number can be called X, Y, anything you want. I wanted to put a number which is a kind of weird, but before the previous time I did this workshop, I put X. And people were confused of what is X, is it a number or something? So I said a number, so you understand that it is a number, it's a number of the list. Yes?
Can you have it print to a file rather than...
Yes, we are going to explain where to print it in a file tomorrow, to deal with file. Of course, you can go through each element of the list and say, I'm going to print it in that file, to save it in that file. Other questions? Yes?
This is just like when you want to apply something to all the values.
Sorry?
Well, this is when you would want to transform all the values or like apply the same.
So your question is, why do we use for loops in general? It's, as always, all the time, that can I come up with a clear example right now? Typically, you want to, so for example, an easy way to see that, you have A, which is, it's 1, 2, 3, 4, 5. And you want to create another list based on that. So let's just say B is going to be an empty list, and going to be for I, which is just the name I choose, in A, and going to do append. So I'm going to add subsequently new element to the list, and just say the square value of I. So we go through each element of A, take the square, and we'll add it to a B. So at the end, B will be just the square value of all these numbers, for instance. Or like you have plenty of files, so just plenty of strings, and you want to apply the same thing for all the files. For each element in the list of all the files, I'm going to open the file to do stuff like that. We are using pretty much all the time, for real. Okay, other questions? Yeah, I'm going to put plenty of examples after that. Yeah, just to mention it, you can make for loops for dictionaries. It's not that for that is not that common, but why not? And when you do it for a key in my dictionary, in fact, a key will be subsequently each of the keys of the dictionary. So here I go through. For a key in my dictionary, I'm going to print a string, which is key. Oh, I'm going to insert a string here. I'm going to see at the end what it is. And the value is going to be an integer. Percentage I is for an integer. The first element I'm going to insert is a key. So it will be inserted here. And I'm going to insert here what is the value corresponding to a key into my dictionary. Okay, so it'll go through each of the keys and print it. So it will be print x1 value 100, etc. Be careful. So here it happens to be in the right order, but be careful. It's not always the case. It can be a different order. So the order won't matter, but at least it will go through all of the different keys. Okay. Guarantee that you go through all the different keys, but not in the specific order. Okay. Yes?
So does the percent S, percent I, and I think there's a percent F too, do they all mean differently?
Yes. So it's when you want to display a number in a nice way, a number or a string or whatever in a nice way. Percentage something IF is meaning I'm going to insert something. But how am I going to display it? Am I going to display it like a float number with 2 decimal precision? It's a very convenient way to do it. So just percentage point to F means I'm going to insert it into the format. I know that the real float number has plenty of decimal. We're just interested in the 2 first. We can do that. Percentage AI is going to say I'm going to insert it looking like an integer. Okay. It's just a nice way to display it. You also have the percentage E. Percentage E, so if you have something like that, print. Percentage, and here you are going to put a number like 3,000, 103.3 here. So I'm going to take that number, but display it like at 3.123 E 123. Okay. So percentage E is going to display it with the scientific notation. Yeah. So percent F E I S, and I think that's all.
You said S means to insert
A string.
is to what?
A string.
Oh, straight. Okay.
Other questions? You can also make a for loop with strings. So here my string, which is Python, and my new string is just for now an empty string. So just quote. It means that a string that contains absolutely nothing. And I make a for loop for a letter in my string. So a letter will be subsequently each of the different characters. I'm going to, oh yeah, I forgot to change the order of the slides, so there's some things, some details that. So what is this kind of plus equal here? It's very simple. Plus equal, so if you have x plus equal 1, it's exactly the same thing as saying x is equals to x plus 1. Okay? Exactly the same thing. So you're just adding something to the value. Okay? So it was going to solve that. You already knew what was x before, otherwise it won't work. It will solve x plus 1 and put it in the same value here. So exactly what it's doing here. You can do the same thing with multiply equal, divide equal, minus equal. It will be just you replace the operator here. Okay. Sorry. So you have that. So my new string is going to be minus string plus 2 times a letter. So a letter will be subsequently p, y, etc. When you multiply a string by an integer, it just like duplicate as many times as there is an integer. So it will duplicate p. Sorry, it will duplicate p. Sorry, it will duplicate p, then y, then t, etc. And make it 2 times, and it's going to glue it to my new strings at that time. So let's just go through the first step. A letter is going to be the first character, which is p, and going to add to my new string, which is for now empty, 2 times p. So it's going to be p. Okay? I go through the second step of the for loop. A letter is going to be y here. I'm going to add to my new string that is for now pp. I'm going to add 2 times y, so it's going to be ppyy, etc., 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 until the end. So at the end, my new string is going to be ppyy, etc. Yes? Okay, I'm coming. Okay. So yeah, so for loops for list is just each element of the list. For loops in dictionary is just each key of the dictionary. For loops in strings is just each character of the string. Quite straightforward. Okay.
I'm sorry, would you mind explaining the plus equals again?
Yeah. So let's just take an okay. I'm going to take an example on this guy here. Okay. So x is going to be 1. Okay, and if I do x plus equal, so for example 5, it displays nothing. It's just going to be x equals 6. So it's exactly the same thing as saying x equal x plus 5. Okay? Exactly the same thing. Just like programmers are lazy people, that's the common rule. Okay? Is it clear for everyone? You can do the same thing like, so here x is equals to 6. I can make like, where is the star? Yeah. So 2 is equals 2. So here I'm going to say x is equal x times 2. So if I then ask what is x, it will be 12. Okay, that is a small difference. It won't matter in, I would say, everyday life of programmer. There's not a big difference between Python 2 and Python 3. But in order for me to explain what is the range function, I need to go through that. Just, yeah, something a little bit annoying, but I need to go through that to explain to you what is range function. But in everyday programming, as we use range function for loops, it will be the same as what I say here, same syntax for loops. So when you are in Python 2, when you say, I want range 10, it will give me all the number from 0 up to 10, without including 10, is always the same logic. So it gives me back a list directly. That will be a list 0, 1, 2, 3, 4, 5, up to 9. If you do it in Python 3, it will give you a range of 10. It gives you back, it says, oh, it's going to be an object called range from 0 up to 10. And said, what do I do with that? And you can force Python to say, okay, transform that object into a list. I force it to transform it into a list. So I'm going to do list of a range of 10 and gives me back what it means by 0 up to 10. It's just for efficiency reasons that they transfer that. I'm not too much into the detail. So we are going to test what is the function range. I'm just always going to put lists and into parentheses what is range of what I'm going to test. But in the for loop, you will see that we're just going to get rid of the lists around and it will work perfectly fine. Okay? Okay, so let's test it. List of range 10. So as I told you, is all the number from 0 up to 10 without including 10. So 0, 1, 2, 3, 4, 5, etc. up to 9. you can specify if you want the starting point. So if you don't specify it, it will begin from 0. And here I'll take an example. Okay, so 0, but you could put 5. It will be all the number from 5 up to 10 without including 10. You can also specify the step. So like here it means that I want all the number starting from 0 down to -10 without including -10. That's weird. Normally we want all the number, increasing number, but you can specify a negative step. So it makes sense. I want from 0 down to -10 without including -10 at step -1. So 0, -1, etc. to -9. What if I do range of 0? So it means since I do not specify the first one, it means I do not specify the starting point, but it's by default by 0. So I want all the number from 0 up to 0 without including 0 and just an empty list. Okay, so here I'm creating an object called myRange. And it's going to be just range. Don't put the list around, just put an object range from 0 up to 10 at step 3. Okay? And I'm going to use that object called myRange in a for loop. For num, just a new num, why not? A number, whatever you want. In myRange, column, if there is a column, the next line is an annotation, print the number. So it will print all the number into this range object. So it's all the number from 0 up to 10 without including 10. So in fact, at step 3. So it will be 0, 3, 6, 9. Okay? It works for everyone. No questions? Okay. So here we're going to make a function which is which can be useful when you have a biological application. It will find the reverse complement. So I don't know if maybe I will explain what is the reverse complement. It's very simple because yeah, I know maybe some of you are not biology coming from biology. I don't know. Do I need to explain what is a reverse complement? No? Oh, yes, okay. So you have nucleotides, A, T, G, C, G, G, C, etc. You have a sequence, and you want to have the reverse complement. So you need to do two things. The opposite of the complementary nucleotide of G is going to be C, and the other way around. The complementary nucleotide of A is a T, and the complement of T is a A. So basically, GC. So that will be just the complement, and the reverse complement is doing that, but also doing something else, which is just to flip that sequence like that. So at the end, you want to have C, G, A, T. So that is complement, and that is reverse. So basically, we want to do those two operations. Okay? So, how do we do that? So we can take a piece of paper and write a pseudocode to help ourselves. So we are going to have a sequence. So we say for each nucleotide in the sequence, I want to do something. If the nucleotide is an A, then I'm going to prepend. So I'm going to explain what is that because it's the magic of the algorithm. The complement sequence with a T. Okay, so I have sequence, I have a complement sequence, and I'm going to fill little by little complement sequence by different nucleotides. So I'm going to prepend the complement sequence with the T. So here you see a so and we are replacing by a T. So it's more the complement aspect. How do I do the reverse aspect? Is with the prepend. So what do I mean by the prepending? is I'm going to add from the left. So, so here I will have out of my sequence. Let's just say it's A, G, G. Okay. At the beginning, it's just going to be an empty string. So at the sequence, I want to take the reverse complement of that sequence. And for that, I will store it into a reverse complement. For now, it's just an empty string. So I'm going to do for nuc in sec. So I'm going to go through each of this of the nucleated sequence, and I'm going to add the complement. So if it's an A, I'm going to add from the left, in fact, to reverse complement a T. So I am going to add it that way. So for the first step of the for loop, it's going to be red, com. So I have this empty string, and I add from the left the complement of the A, which is a T. So for the first step, reverse complement will be a T. When I go through the second step, which is a G here, and I'm going to take back this reverse complement, and I will add from the left the complement of G, which is a C. Okay? So I add from the left, add it here. I continue for this last sequence. The complement of the G is a C, and I'm going to add it from the left from the previous reverse complement. C, C, T. So in fact, you add from the left several times, and it will automatically make the reverse aspect of the algorithm. Does it make sense? So it's kind of nice way of doing it, right? It's eloquent way to do it. Rather than doing it in two steps, first finding the complement, then making the reverse, we're doing that almost at the same time, which is kind of nice, right? So we're going to program that. So we're going to create a script. So open your text editor, text edit, notepad, whatever you want, and let's continue. Okay, so we are going to ask the user to put the sequence. So we are going to need to access to sys.argv. So let's just import the module sys at first. Okay, I'll go to the line, and I'm going to create a function called reverse comp, and I put like a small comment to explain what I'm doing, print the reverse complement of the sequence. So reverse complement is going to be sequence, so it's introduced by def, the name of the function, and it will have one parameter, which is going to be the sequence. Column, I go to the line, and I print it. So I create, so it's not the reverse complement, it's rcsec, which is going to be an empty string for now, okay? And I'm going to fill rcsec by the reverse complement, the complement of the sequence. So for each nucleotide in the sequence, so I will go through the sequence here, I'm going to do something, which is I'm going to check that the nucleotide with that nuke, which is a string just with one character, is indeed in A, G, C, T. Because if it's not a sequence, you prefer to say to the user, okay, something is wrong, be careful, you are not giving me proper information, you are doing something wrong. So we are a step where we're checking that each of the nucleotide is in A, G, or C, A, G, C, or T. If it's not the case, that I'm going to print. So %s means I'm going to insert a string here. It's not a nucleotide, and I'm going to insert what is nuc here. I will explain the return empty string later. Why do this? Just put it, and be careful about the annotation. Each time you see a column, you need to add the annotation of the next line, and maybe the subsequent one. So here, all those lines need to be aligned. After the for loop, that's the definition of the for loop. That's the definition of the if statement. Okay. Continue. Okay. If it's not the case, else, I'm doing something else. So I'm going to say nuke. If I'm going to look if nuke is equal to A. If it's an A, then I'm going to prepend a T, right? So I'm going to say rcsec is going to be equal to T, the complement of A, and I'm going to add it from the left. And then I add rcsec. Yes?
Why the two equal sign?
The two equal sign is when you ask a question to Python, is that thing is equal to that? Which is different than the single equal, that the single equal is saying assigning. And you do the same for all the other nucleotides. If it's a T, you prepend an A. If it's a G, you prepend C. If it's a G, you prepend an C. And don't forget the last line is the one that personally I always forget, is the returning of the results. So here you are returning rcsec, and be careful about the alignment. It's after the for loop that you are going to return the results. So be sure that this return rcsec is aligned with the for and the rcsec here. Otherwise, you have some problems. I'm just going to check this line. Yeah. Okay, so once you have that, don't worry, you have time to finish to write. I'm going to say, okay, so my sequence, so outside from the definition of a function, I'm going to use that function, and I'm going to apply it for sys.argv1, which would be the information that the user is putting here, and I'm going to execute the reverse complement on that sequence. I'm going to store the information into my sequence here. And then I just print the result. So print just one string that where I'm going to insert one element, which is my sequence. I'm going to put it here. I save the file. That is a script. So you are going to execute it from outside Python. So you be sure to have the prompt that you do not have the feature runs. You are outside Python. You put Python 3, the name of the file. I choose it to name it revcomp. Be sure to save it in the home directory. And with whatever sequence I want. And be sure that the result that is printed is the reverse complement. So the case from the right hand side, AAA, GG, C, AAT. So, question. What part of the code makes it add from the left? So it's in fact when you look at, for example, this line, here you have rcsec, the previous string rcsec, and you are going to add from the left. So you're going to have the T here is on the left with whatever rcsec was equals to, and you grid from here. If I put the T on the right hand side, it will add it from the right, but here we are going to add it from the left. Hope it makes sense. Okay? If you have bugs, raise your hand. I'm coming. I'm helping you. Who has managed to finish that? Raise your hand if you have. Okay, so not everyone for sure. weird bugs, things like that, raise your hand. And so off. Okay. Oh, sorry.
So let's just start with the beginning. As I said, it's just going to be a string that contains nothing. Okay? And I'm going to fill that string little by little when I do the for loop. So each step of the for loop, I'm going to add the new things into SSA. Yeah, it will be the result at the end, but that's an object. For now, it's empty, and I'm going to fill it with the okay. So a reverse complement is just a function. So what Python gives you is oh, I'm going to define a function. So I'm going to put the box, put the definition inside, and that's all. And then you are going to use that function to the reverse complement. So you're going to call that function with a parameter sys.id, which is whatever the user is here. And I'm going to execute the function with that target. So Python goes back in the definition function. We replace each time it's set by here. And execute basically all of that. With a result instead.
So the two last time. So here you define a function. Okay. So Python is a box, the definition inside, and has done nothing else. Here you are going to use the function. This reverse complement, release com is that function. So you are going to call that function with that particular parameter. The particular parameter is in order to access to whatever the user is putting at the end. Okay, so.
Oh, so this is just so that I can not be
Yes. So when you do Python, the name of your script, Python will execute all of that. So we go here, we import this, it will define a function, and then it will arrive to that line where it needs to use the function that you have defined. with that parameter. It executes all of those things here, and it gives you the result. So that get here is going to be the result. We store it into my sequence. Then it goes to the next line and prints it.
Or like when you use hours.
No. In Python, the annotation is mandatory. If you don't use it, there is going to have a problem.
Right. For what I meant is like what if I use instead of house there, just
So else if, you can use else if, but you need to put something after the else if, like else if nuke is an A, something, oh, okay. So what you want to do is rather than having else and then if, etc., I can use directly put all those guys to indent it and use else if, else if, else if, else if. It will work.
So sorry, but exactly what part of this makes it so much use? I understand the reverse comp is a function. So what did you do?
So just something, I don't know if it's useful. Reverse comp.py refers to the name of the file. And the reverse comp is the name of the function, which is different. So that is not directly referring to the name of the function, it's referring to the file, in which file you're using the function reverse comp.
So is this one already built into the to add it in reverse?
No, the adding in reverse, so it's the pretending. So it's what I explained is that's on the left. The magical line that I'm doing that is the reverse. So here SESEC is what was SESEC just before. And here you find an A as an initial text, so you're going to pretend, so add on the left the complement of A. So you see the T here is added from the left. So the left. It was SESEC plus T from the right. So it adds it from the left, it's a value, and then you have the reverse.
Could you do it like this size as it was not on the
What?
Like could you do it where like if it's a T then it's as it is to the right?
Yes, you just change this line and here add it from the right. You do SESEC plus A, that in the case, if a nuke is a T, it adds an A to the right,
Okay.
and you have a call. Yes. So I found the something very simple. So SESEC is the means for you. It's welcome in the world of programmers. It's always like typo, it's uppercase, lowercase. Things like that. Okay, who managed to finish that? So for those who didn't raise their hand, actually want to see you and help? Yeah. Okay. What are you? Oh, fine. Yes, fine. Notation. Look at where is your less else identity? It's one notation in addition to the for. Should be for. And here the else at the same level. It should be one because it's part of the definition of a for loop. So basically, what Python does, it just goes through one of them, and that's all. Else and all the rest.
that's our yeah. Yes. With that. Invitation. So, so the way you all of that as you can see. All of that because it's all invitation as it is. So basically what you see is that you see for the set, and then you see this compact switching, which is returning the result. And what you want is that it goes through each of them. And at the very end, when the for loop is finished, so as you can see from the slide, the return, the notation of the return is at the same level. So you have first. Okay. See? Okay, oh, no. Use that. Normally baseline fish is okay, I will just finish okay. So
Yeah. I explain what is the return empty string. So here you can see that there is return empty string here. It means that I'm going to return nothing if the nucleotide is not in AGC. The thing is, so when you test with something which is not a nucleotide, it prints you that. It says X is not a nucleotide. And it does nothing else. The thing is, if you don't put this return empty string, so here I remove that line here, as you can see. If you do that, then it will go through that. He said, oh, there's an X here which is not in A, G, C, and T. It prints that line, but then it goes in the for loop as if nothing happened. And you continue to do it, and you find the reverse complement, and returning at the end. So it's not always a good behavior to add that. If something is weird, you prefer to stop the program before and not continuing and telling the user something is wrong, you're doing something wrong, rather than continuing as if nothing happened. So it's why I put return empty string. You can like, the convention is more like return false, return a boolean which is false, saying something wrong happened, or even throw an error, as I will explain tomorrow. Okay, so that is not that incredible. I just, rather than having 2 lines here, I'm just going to have just 1 line. So I put like the reverse comp of sys.iv1. I replace my sequence by that. Nothing incredible. Yeah, I try to finish that. It's okay, that's just a very small improvement. But here we are going to make a huge improvement. So just by looking at your code here, you see that you're always doing the same kind of thing over and over and just like doing it again and again. If it's an A, then add a T. If it's a T, and a, it's kind of boring to say all of that, right? And usually when you see that, you can have an idea that maybe there is a more eloquent way to do it, to write it down. Maybe it's something less heavy to do. So maybe we can, rather having 8 lines, maybe we can have just having 2 lines doing exactly the same thing. Yep, okay. Okay, so we need an object that basically gives us the complement, right? So it's an object. If I feed it with an A, it should return me a T. If I feed it with a C, I should return it G, etc. What kind of objects we have talked about that can make this function? Right? Right? It's the only thing we want. We want an object, giving it an A, it returns me a T. Dictionaries, exactly. So we have a dictionary, the key will be the nucleotide, and the value will be the reverse, right? So rather than having those 8 lines, we are going to put just 2 lines. So all the 8 lines here are going to be replaced by 1, and I'm just going to add just a very small at the beginning. So reverse, comp dix is going to be the complementary dictionary. So here are 4 elements here. The key A have the value T, the key T have the value A, the key C have the value G, and the key G have the value C. I've defined that, and then I go back here, I remove all the 8 lines, I just replace it by just 1, and I'm going to prepend to rcsec whatever is the value corresponding to the key NEC in comp dix. Okay, so if the nucleotide is a T, it will go through comp dix, so it goes through that guy. You look at what is the value corresponding to the KT, it's an A, and it's going to prepend it, right? And the same as well. So rather than having 8 lines, you just have 2. It's very adequate, right? You can save it in another one, which is like revcomp dictionary, another file, and compare the 2 results, it should be the same. So that was with the old version, the 8-line version. That is with the dictionary version. Yes?
Could you explain the print line again?
Okay. So the print line here is just a string. I'm going to insert a string here. Okay, I'm going to insert something here, which would be the result of that function here with that parameter. So what Python will do at first, it will go, oh, that's a function that I defined. I'm going to execute it with that parameter. So that's the first thing it's going to execute. It goes here, replace sake by sys.iv1. It do all these things and returns the result. So the result of that function is going to be that guy here. I'm going to insert the result here and going to print the result. Okay. Everybody has done that? Do it, and I will end for today. We'll look at, yeah, I will go on later. Okay? Do you have question offline, maybe? Yeah, so this has been yes. Does it mean that Python goes through all the code until it gets to print? Yes. So basically what it does, Python does, so when you are in your terminal, you print that, you type that that line of command, you hit return. What Python is doing is going in that script, execute this first line here, import sys, then it goes here, it defines the function, so it opens the box, it put the definition of a function here, and then he goes through that line. And that line contains plenty of things. So the first thing that he's going to do is look at this guy here. He's going to use the function it has defined with that parameter. It will go through the definition of the function, execute all those lines here, return the results, and will be the result here. Then it inserted it into the string here and display the result with the print statement. So it's doing all of that. Okay, so somebody gives the link to the slides. Okay, so I'm going back.
So,